All right, last time I showed you how to use the business, use the business class and the GUI in combination to check for valid values where there's a lot of, like particularly a valid value out of a combo box. Last semester I showed you how to write a validating routine that in the GUI said you must pick a value from the list. That's not the GUI's job to determine whether or not that's a requirement. That's a rule, so that goes in the business class. So the way we dealt with it is we created an array, and this is your first introduction to an array. Those square brackets after the word string represent an array. An array means I've got a bunch of values, cola, diet cola, ginger ale, grape supreme, but they all have the same variable name. They are all called valid sodas. This is a valid soda, this is a valid soda, this is a valid soda. This is valid soda sub 0. This is valid soda sub 1. They are indexed. And in this unit, the indexes don't make a lot of difference because we never refer to an individual one. But that's how we create an array, and this makes it very simple. Imagine if I needed to have, I think there's what, 15 sodas on that list? I wouldn't want to have 15 variables called valid 1 and valid 2 and valid 3 and valid 4 and valid 5. And then to each one of those assign a value and then have to write an if statement saying if what the user typed is equal to number 1 or number 2 or number 3 or number 4 or number 5. What a pain. Instead, we can use an array and process very quickly. Go ahead.
Can you touch back, what does the static stand for?
Okay. The static kind of goes back to the same thing we did with the dates. We want these to be constant so that they can't be changed.
Right.
My list of valid sodas can't be changed. Okay, and that's the read-only.
Right.
The static says it belongs to the class, not to an instance. It belongs to the cookie cutter, not to a cookie.
Oh.
Every pizza order has the same list of valid sodas. Every pizza order has the same min and max days. And so when we ask for this information, and we'll see it, when we ask for this information, we have to ask the pizza order to give it to us, not an order. We have to ask the class directly, not an order to give us that information. Good question. We need one more today, so let's add it real quick here. Another public static. It's still going to be read-only. It's still going to be a string array of valid sizes. Go ahead.
Did you clear out the load sodas or comment it out when you did this?
No, we used them in load sodas. I'll show you that in a second. I just want to add this one real quick. Small, medium, and large. So those are my acceptable sizes, and we'll use that to validate here in just a second. Because the GUI is using radio buttons to pick the size. There's really no way for the user to screw that up, right? However, our business class really can't make the assumption that the GUI is going to do this right. For all we know, the business class has decided, the programmer of the business class has decided that they're going to use a text box to collect the size, and you have to type small, personal, medium, or large. We have to type it, then we really ought to validate it. There's an outside chance that the user of who's using our class will mistype one of these, so then they'll get yelled at. But when you're writing code in a business class, you have to assume, what I like to assume is that everything's coming from a text box. If everything's coming from a text box, other than Booleans, there's really no way for that to happen. I'm not worried about that one. But anything else, I want to validate it to make sure it's acceptable. Matt's question is, did I change form load? It was never in form load, it's in initialize form. Okay, here's form load. Oh, there's load sodas. Okay. I have a method called load sodas that's in initialize form. You don't have that one?
No, I was just wondering if you changed it because the load sodas wasn't that set to a different.
The fixed list, yes.
Yeah,
and yes, we did change it to a fixed list. So I'm going to go look in load sodas now. So here's my load sodas method, and inside there, here's the fixed list that was there. We removed it.
Okay.
Initially, we used a for loop that says walk through every soda in the list And this is a valuable skill to recognize. This use a for loop to walk through each item. Now, right now, there's a shorter way, but it's a valuable skill to have. That's why I'm leaving it here so you can use it as a reference. This says, for each one of the string sodas on the list, this better be a list of strings. For each one of those in this array of valid sodas, add it to the combo box. But this piece of code got written so often that the Microsoft geniuses said, you know, why don't we just write this routine called add range that takes an array of strings and adds them to a combo box. So this does exactly the same thing as that. It's just a little shorter for us. But not everything we want to do to an array in the future. Not everything we want to do to an array gets done for us automatically. They haven't anticipated all of it yet, but this is one they anticipated. So they gave us a method that does this. Takes this array, stuffs it into the combo box. That's what this did, but this does it for us automatically. So that's where I did that. Now the next thing we want to do is for our radio buttons, make sure that whatever gets sent in there is acceptable. So I'm going back to the business class now, and I have a list of valid sizes. I'm going to say that the logic for checking to see if the size is on the list is going to be the same as the logic to check to see if the soda was on the list. So we should be able to steal that. So here's our soda. We said if the value double equals the empty string. All right, now that's going to have to go, right? Because we got to have size. Or the list of sodas contain. Remember this, the trouble we had with it? And thanks to Sam, I sorted it out and talked to you about it. But what the problem was is I had done one of these right-click and organized my usings, and I removed all the unused usings. Oops. That worked fine, except now when I wanted to say contains, it said, no, I never heard of it before. What's really bizarre is that contains comes from this system.link. Link is Microsoft's attempt to simplify databases. Works great. I have no idea why contains is hiding in there. It's an array function method. I don't know why it's in there, but that's where it is. So that's why it didn't work last time. So in your business class, my new advice is don't remove any of the usings until you're done. And even that may not be real sound advice. Should be pretty good, because in the future you might add something else and then the using clause isn't there. If you know it works and it's not working, you're probably missing a using clause. And I don't care if you clean these up. The stuff you send to me doesn't bother me. In the real world, every one of these that I'm using is probably using up some memory. And if I'm not using the using, then I shouldn't be using that memory of it anyways. So I think it's not a bad idea to remove them, but I'll bet Microsoft's also got a compiler that's pretty smart going, geez, he's not using any of this stuff. Pitch it. I would hope so. Okay, so back to validation. I want to steal the validation for soda. Take all of this, the whole set, and I want to validate my size in pretty much the same way. Now I got to change stuff. I don't want empty ones. The size has to be provided. And I'm not checking valid sodas, I'm checking valid sizes. And I'm setting the size. You must select a size from this list. Now that this list part, we are right now, it just says that's not on the list. We are going to add something to this today to let it give us that list. But let's see if that works. Now, how can I screw this up? Every one of these should be on the list. First thing to test is, does it recognize all the acceptable ones? Second thing is, does it recognize a bad one? I believe these radio buttons are all already tied to the same event. It's in the check changed event. And they're all tied to that. I don't know if there probably is a validating event for radio buttons, But then I have to leave the radio button before that kicks in. And with radio buttons on the screen, they immediately change. I think behind the scenes, they should immediately change. Don't force me to leave. So we already have the check changed event. So now I'm going to go modify. Oops, I don't need to. It's already there. This says, oh, except the message box, right? This says, take the senders, the radio button that caused this event, take their text. So the text here is personal, small, medium, and large. Just so happens that's exactly what I'm looking for. That's convenient. No, it's called pre-planning and smart. Now, if my database is storing P, S, L, and M instead of the whole word, then I have to do a little translation, but even that's not bad. But in this case, my valid values are actually what's on the radio buttons. So that simplifies things a little bit. This code says, take the text that's on the radio button that caused this event to occur and put it into the business class. If the business class throws a fit, it's an error. Then show a message box. Nah, that's not what I want. I want to show my error marker. But for who? Because remember, when you set the error marker, you have to set it for somebody, right? For who? This button, that button, that button. Sometimes I put it on the last button. That's an option. Okay. Another option here, though, is I have a group box that all these are tucked inside and it doesn't have a name. So I'm quickly going to give it a name. Call it group size. And I can put the error marker on the group box. And so then it would sit out here. So I could attach it to this radio button, or I could attach it to the group box. I'm going to attach it to the group box. And I still use the EX message. Now my first test is to make sure that all of the radio buttons, that I can click on all of them and not cause any trouble. Another thing to recognize for a little later, none of these are selected. This is a required field, right? If you don't pick any, that's a problem. Click, no error. Click, click, click. Cool, it recognizes all of those. And now, just to make sure that everything works properly, I'm going to change the text on this radio button. Run it again, and click that radio button. I should get my error message. Okay, so that works. If I click a different one, it should go away. Whoops. You guys forgot to help me with that. It's your fault. Just like all the others. It's no different. All of these validating check changed events all look pretty much the same. The only thing that might be different is some of them we recapitalized or reformatted somehow, but other than that, they look the same. The logic is pretty much the same. There's my errors, and that clears it back up. Once I've verified that my class is working, I can put these back, and that error should never appear, right? Should never see that error again. But actually, I'm not done testing yet, so let's leave that on there. Hopefully, I'll remember to take it off. So that's how we use arrays, to check to make sure that the user's selection is on a list that we got from someplace. We can use an array to do that. When we get to databases, there's another way to do it, and we'll see that. But for right now, this is a handy technique for a fixed list of sizes, fixed list of sodas. Today's topic, this is not necessarily related to validation. taking a slight validation pause here. It is applied to validation, but it's a much broader topic than that. Programmer-defined methods. We've already built some. You might not recognize them, but we've done programmer-defined methods like load sodas. That's not an event. It's not built into the language. This is one we built. And the ones we built so far, initialize form and load sodas, are very simple. It's just a method that we created. Why? Why do I want to use a method? Think systems. Jeez. Decomposition, first of all, there is one reason. I want to take a big process and break it down into parts. Instead of form load being really busy with all that stuff with load sodas and all the stuff that's in initialized form, load soda, or form load, excuse me, calls load soda, says do your job. And initialize form, do your job. That decomposition, if I need to, if I'm the maintenance programmer, allows me to say, okay, he's loading the sodas, that's fine. He's initializing, I wonder what he's doing in initialized form. If I don't care, I can come down here and look. If I do care, I'm sorry. I can come down here and look. If I already know what that's doing, I can skip over it. So that's part of decomposition, taking a large process and breaking it down into smaller tasks. That's one reason we do these methods. What do we get out of decomposition besides breaking up big processes?
Easier repair.
Pardon me?
Easier to repair.
Easier to repair, get easier maintenance, but we also potentially get reusability. Now in this case, these are not reusable. This load sodas. Okay, if I have another program that's connected to my pizza order shop that has the list of sodas that are called valid sodas, okay, I could reuse that method. But initialize form, every form is pretty specific. So here it's just a matter of decomposition. In my business class, there is one custom method or programmer-defined method called order total. In this case, it is once again about decomposition. I want to manage orders. Well, I got to have their totals, and I got to have a lot of stuff I have to manage. One of the things I want my class to do is calculate an order total. But notice that this one's defined a little differently. All the ones over here are void pizza load, void initialize form, void load sodas. The parentheses are empty. Here, there's a decimal in the front. These are private. This one's public. What are the rules? What are all these things for? What's this thing for? What's the parentheses for? This is one example of a custom programmer-defined method that is inside the class. In the class, they're called custom methods. They're not properties, they're methods. They do things. Properties store values. Here, we're doing something. We defined another method called toString that was an override of one that's built in. It has a name, toString. It is public. It has string here, not decimal, not void. Still doesn't have anything in the parentheses. We need another one now. I want to be able to, remember my error message says you must pick from this list. You must pick a soda from this list. You must pick a size from this list. I need what I want is a utility that helps me take an array of values, stack them on top of each other in one big string so I can tack them onto that error message. So what I want is a method that in this case is going to be reusable. It's also pretty flexible. It'll take any array of strings, any array. Take them apart, stack them on top of each other, and send you back a single string. It's a custom class. And its name is MakeString, so it'll come tucked under here. Not a custom class, a custom method, excuse me. This method converts an array of strings into a single string. In my notes now. When we define a method, we have to pick private or public. This notation that you see here, square brackets, you'll often see this in the Microsoft documentation. You'll see it in all kinds of documentation where people are trying to describe the general format of this. Square brackets mean optional. Now, this is not C#, this is my notes. This is documentation. In C#, the square brackets mean an array. Here, it means optional. Private, the vertical bar means or, public. Pick one. It's either private or public, or if you leave it out, it becomes public. My standards say when you're defining methods, there's no leaving it out. You can, but I don't want that have to read between the lines, oh, this is public because he didn't say it was public. I want you to explicitly define its scope. It's either private or public. If it's in the GUI, it's probably private. Private means not shared with anybody outside of this file, as in the GUI form file. If I put these into a class, which is what I'm getting ready to do, private means the class can use it, but the user of the class, the outside world, can't use it. They can't see it. If I make it public, like these other ones, that means it can be used inside the class and outside the class. Anybody who's using this class can reference those and use them. So you have to decide. So that's the first thing I want to do for my MakeStringFromArray here is decide, is it public or is it private? Do I want the user to have access to this? Or is it just a utility that I'm using inside? Right now, it's just a utility that I'm using to take my validation arrays and turn them into a string. It's not the job of a coupon to make a string into an array. So it's a little utility that's inside. So I'm going to decide that I want to make this private. You, the programmer of this, get to decide. Is it a utility that only your class uses? Or is it one that people outside of the class might want to use? My advice, make it private. Then when you figure out you need it on the outside, switch it. Maybe you need it, maybe somebody else is using your class and saying, where did you get that list of valid sodas? And so, well, I have this method that converts an array. Oh, why can't I have access to that in my GUI? Why do you need it is my first question. And then they give me a valid reason. I go, okay, turn it into public, done. Now they have access to it. I tend to start private. Now, when we were talking before about the order total, I want the GUI to be able to ask for that and display it, so that one should be public. I want the GUI to be able to take my string version of the class and do something with it. So that one, and in this case, we don't have any choice. Because the original toString is public, we can't change that. Remember, we're doing an override here of something that already exists. But on this one, we could have said it's private. But then how does the GUI display the order? How does the GUI even ask for it if it's private? But this method that we're writing is just a utility for inside. So that's the first thing you got to figure out. The next thing you want to figure out is the method type. Some methods do something and then they're done. Remember my experts, I call them and I say, do this for me. And they do something and then they say, I'm done, and we hang up. But they don't give me anything back. They just do whatever we told them to do. They don't send anything back. Other methods send something back. They do magic and they send something back. For instance, the order total. The order total goes through a bunch of gyrations, and in the end, it returns the total for this order. It sends something back. Many functions send something back. ToString sends something back. Our job when we're defining the function is to determine the type of whatever's coming back. My function that makes a string out of an array, the name pretty much tells you what it's sending back. What's it sending back? String. A function can only, without jumping through more hoops than it's worth, a function returns, if it returns a value, returns one and only one value. Swift has changed that. Now I can now send back an array from a function in Swift, but most languages, you send back one value. That thing that you send back can be a primitive type, a double, an integer, a string, or it could be an object, a pizza order. I can send back a whole order. As long as it's one thing, I can send back one thing. An array is not one thing, it's a bunch of things. So when we define our own methods, we first have to define its scope, private or public. Then we have to determine, is this method going to send something back? And this is, you're thinking up this method. Right? Granted, I'm going to ask you to build some. Right? But you have to ask, what type of data does it send back? Sometimes the answer is none. Like load sodas. When load sodas is done, it doesn't send anything back to form load. It just works with the combo box directly, and it says, I'm done. Doesn't send anything back. If your method doesn't send anything back, you must declare void. Once upon a time, I dreamt this up. I've never seen it anywhere else. Void is the type of nothing. So if you're sending nothing back, we still have to designate the type, like string, decimal, double, order. In this case, I'm sending nothing. What do I put there? Not nothing. Void. Void is the type of nothing. So in here, we have to put the type. And if we're not sending anything back, we put in void. Then after you've designated all that fun stuff, then you finally get to pick a name for the method. I usually follow the C# examples and use title case. So the name for this method is MakeStringFromArray. As you get more and more experienced, your names become longer, and if you ever do iOS programming, their names are like this long, they hardly fit on the screen. Make string from an array. That's the name of my function. That's how I refer to it. It's like declaring like creating a department in your company. You give it a name so they have something to put above their door, and you can call them and they say, hi, it's me, finance department, I know. It says it above the door. In order to invoke this function, we simply call it by name and say, make a string from an array. Following the name are a list of parameters. Parm here is short for parameter. Parameter is information that I need to send to the method in order for it to do its job. So a method can receive information, but it usually sends back one or none things. Notice how many parameters we can have here. As many as you deem necessary in your function, in your method. If I need 6 pieces of information, then every time you call me, you have to provide these 6 pieces of information. Some methods, many methods, don't require any. That's where the empty parentheses come from. If I need to send something in, remember I think I called it an envelope once upon a time. If I need to send something in, I put it in the parentheses. If there's nothing there, that means this method, you call it and say, do your job, and it goes, yes sir, smart, absolutely, and go on. They don't need any additional information from me. Don't need anything. Don't need anything. Have we written any? We didn't write these. Notice these have 2 parameters, the sender and the arguments for the event. The sender and the arguments. The sender and the arguments, a little different kind of arguments. Key press arguments. But we didn't write those. Form load. All of these have the same kind of structure, right? Private, void, the name of the method. And then what information do you need to know? Who caused it and what other information is it? So back to mine. I want to make a string from an array. Picked on Lyle last time, so I think to make things complicated, I'll pick on Kyle this time. I'm not picking on, just using him as the example. I'm going to hire Kyle to make a string out of an array for me. He's going to be my magician. What does he need to know to do his job? Pardon me? Say it. Which array? Because he's so powerful and almighty magician that he is, he can take any array, as long as it's got strings in it. Doesn't even have to have that. He can take any array and turn it into one string all stacked on top of it. So he needs to know, which array do you want me to convert? When you send information in, you have to type it. What type is it? He's basically saying, here's how you call me. I'm private, so you better be inside my company. You can't call me from outside the company. My name is MakeStringFromArray, and you have to send me an array of strings. When I'm done, I will send you a string back. This is called the signature of the array, or the signature of the method. And in Kyle's case, he needs an array of strings to chew on. He does his magic and he sends you back a single string. The other thing that we, the programmer, have to provide here is, what's Kyle going to call this array? He has to give it a name. Like what? Valid sodas? No, because I could be sending him valid sizes. That would be a dumb name. I usually pick an even dumber name. The array. You need to send me an array. Here's the array. Send it to me. Then he's going to do his work. The last thing that Kyle's going to do is return a string. So just to make the red squiggles go away, I'm going to return nothing. Because he promised, right here, he promised, I will send you a string when I'm done. If you designate a return type, you must have a return statement at the end that has the right type attached to it. We're going to build lots and lots of functions, methods, procedures, because in every language they're called something different. But you're going to build so many of these, it's become second nature at some point. Right now, it's a little complicated. But if you keep this pattern in your notes, write it somewhere else, public, private, what are you returning, what's your name, what information do you need to do your job? You can write any function with that information. In any language, they're all pretty much the same. Functions are so important that when you learn JavaScript from me, there's a whole chapter on functions. When you learn PHP, there's a whole chapter on functions. In iOS, I just assume you know them somehow, and we just throw you in there and say, here, write some functions. By the time we get to PHP and JavaScript, they're so ingrained, you don't even care. It's easy. After time. Right now, it's a little confusing. Okay. Before I teach Kyle how to do his job, because I have to. Once I teach him, he does the magic. But let's see how we call those. Remember in size here? I said you must select a size from this list. I'm going to put a \n \r there to start a new line. And then I'm going to concatenate, whatever Kyle sends me. And this is one of the powers of functions, is I can do this. This says, call Kyle. Send him the valid sizes. He goes, thank you very much. He does his magic. And he sends me a string back, which I immediately concatenate to another string. I don't have to save it in a variable right away. I can use it right now. Very, very powerful. So this says, call Kyle, send him this, and whatever he sends you back, tack it onto this. So here's what I envision. You must choose a list. You must choose a size from this list. Next line down, here's the list. And Kyle is sending me a vertical list as well, because that's what I'm training him to do. So I see a message at the top, and then underneath is this list of values. That's what I envision. So that's cool. Now I also want to do the same thing with soda. There it is again. \n \r concatenate. I pressed Control Space and it said, no, that's all I got. And then inside here, I have to send him the valid sodas. Notice I call the same guy, but I give him a different piece of information. And he still sends me back, obviously, a different string. But I can send him any array of strings and he will do his magic. Right now, he sends me back the empty string, because that's all I've trained him to do. We're going to fix that here in just a second. So let me review that. To create a method, you simply designate all its required parts, looking in the notes. How do you know? If you're dreaming up your own, you decide what needs to get sent in, what's coming out. What am I going to call it? Often for me, I will say, create a function or a method to do this. Create a method called this that does this. When you see that and you think about what is it going to do, you have to figure out, does it send me something back or does it just fill up a combo box? You have to figure that out. So most of the time, you're on your own here. You're writing the function. You're writing the method. So you have to decide, what does it do? And how do you communicate with it? That's really what we're talking about up here. How do you communicate with it? You send it an array of strings. You get back a string, and its name is MakeStringFromArray. When you then call it, you call it by name. If it requires a parameter in the parentheses, you have to send it. There's something called optional parameters. We're going to leave that for next year. Where if you send me something, I'll use it. If you don't, I'll make up my own. In this case, that makes no sense. If Kyle's going to turn an array into a string, he needs to have an array. He's not going to make up his own. And if that function returns a value, you then have to do something with that. Well, you don't have to. What if you don't? It goes away into the big bit bucket in the sky and disappears. Kyle does his magic, sends you a string. If you don't put it in a variable or use it right away, it just disappears. It's not an error to not use what you've been sent. It's not real logical, but it's not a syntax error. Okay, let's see if I can write this. What do I want Kyle to do? What's Kyle going to do? He's going to take a look at this array, which he's calling the array, because it's just this array of strings. He doesn't know what I'm calling it. He doesn't even care. Because at one point I call it valid sodas, and another place I call it valid sizes. They're two different arrays. He can process any array. Whatever you send him, he's going to rename it and say, you're the array, or my array, or whatever. Doesn't matter. What it's called on the outside doesn't matter to him because he's in his own little world. It's like those old-time pizza guys or programmer guys. They have their own little closet. You knock on the door saying, I need a program to play Tetris. And he goes, okay, go away. I'll call you when I'm done. He lives in his own little world. And what I call this array, he doesn't care because he's calling it the array. And by the way, he has his own copy of it. He shouldn't mess with it. But if he needed to, he has his own copy. Oh, careful, Volker. C#. No, he gets a copy of mine. Different languages are different. He gets a copy of mine. But he has it, but he's calling it something different. I call it my remote, and he calls it that remote. Doesn't matter. Same remote. Still works. What I want him to do is, first of all, create a string, and we'll call that result. And we'll set it to the empty string. And then I want him to walk through every element of the array. To walk through every element of the array, it's that for each loop we saw when we were doing sodas. For each, parentheses, item, because I don't know what the heck they are. They could be sodas, they could be customers, they could be bowling balls. I don't know what the heck they are. For each item, but I know it's a string, in the array. Let's use a technical term here. For each element in the array, Whenever you have arrays, each part, each one of them is called an element. That's the technical term. Don't need to use it. I can call it whatever I want. For each element in the array, do this. I want to take that element, whatever it is, concatenate it to result. Plus equals, take whatever's in result, add this to the end. And then I want to concatenate a carriage return line feed so that each one is underneath the other. And just for grins, I want to indent them. Started putting spaces in between those just to get rid of the pink. Can you see what this is doing? Can you visualize it? No? Okay. Well, not going to look real good on the recording. But here's what we have. This is the way I picture it. And I'm abbreviating for valid sizes. We have personal, small, medium, and large, but it's got the full words, right? That's what's in that array. What this says is for every, now this, what Kyle is doing is going, yeah, you call it whatever you want. I'm going to call it the array. It's the same array, he's just giving it a different name. Okay, it's like me saying, no, yeah, your name's Kyle, that's fine. But from now on, you're dude. Right? Here's what we're doing. He picks his own name for that, and now the for loop says, for every item in here, for every element, E, abbreviating, for everyone in the array, the for loop is automatically going to walk down these. It's automatically going to quit when it gets to the end. Automatically going to start at the beginning. It's the power of the for each loop. You don't have to tell it how many items there are. It figures it out. It's just so lucky. It says, take that, and oh, by the way, we have this variable called result that right now has nothing in it, empty string. Take this, concatenate it, and move down to the next line. Put some spaces in here too. Okay? Then we hit the top, we hit the bottom. Automatically from the bottom of the for loop, go back up and say go to the next one. Okay. Now E points to that one. Concatenate it. Hit the bottom, go to the next one. Concatenate it. Go to the next one. Concatenate it. Go to the next one. And no more. Take this whole thing, send it back. Never just said that yet. Send it back. Now in my sodas, there's 10, 11, 12, I don't even remember how many sodas. It just walks through it 12 times instead of 4 times. I think we're done. Fingers crossed. Now why have we got extra space there? Where'd that go? Why is there an extra space there? I don't know. When I displayed the error message, I said, give me a carriage return line feed. Maybe I don't need to do that. That's soda. Shut. Why wouldn't I need to do that? I don't know. Seems to me I ought to have to do that. There, indented a little bit. Oh, personal's back up on the same line again. What? I put it in, I got double space, I take it out, I get 1.
You have it was NR before?
Oh.
Yeah, you had NR before and then RN. I was just about to ask you what the difference was.
There shouldn't be any difference if I go down and then back to the left, or if I go to the left and then down, I should end up in the same place. Hmm. Might have to change my notes again. It's been a while, a couple days. Karen's right, I had NR. Maybe when it's RN, it recognizes that that's two carriage return move down things, but when it's NR, it says, oh, that's two separate ones. And it doesn't merge them. Let's see if we get one. So all those backslash RNs I've been teaching you since way back when, just replace them with a backslash N, you'll be okay. So let's prove that. Because we're going to go down to Kyle here and say, hey, Kyle, we got new thing. Don't do that. Wow. I hate programming. Okay, so that one works. So now we can fix that. Let's go in here and put in the Fred soda. What? Oh, I haven't fixed that one yet. Some days I miss Swift. Notice it doesn't matter how many elements are in the array. Now, that's going to be a pretty ugly error message if I have 200 items on it. But I probably wouldn't use it for this if I had 200 items. But in this case, I can tell them the list, and you must select the soda from this list, and hopefully the person will go, oh, look, there's a list. Okay. As soon as I leave, it's happening. The point of that is not that I can take an array of strings and concatenate and turn them into an error message. The point is, I can write my own functions to do something that's reusable, works with any array. Kyle is so flexible, I send him any array and he turns it into a string. There's also a little bit of array processing in there. Arrays are lots of values, all with the same name, all with the same type. And you typically use a for each loop to walk through them and process them somehow. So lots of little lessons learned there. Now that we know how to create methods, we're going to create two more. I still have a problem. If I make errors here, won't let me go to 0 anymore. That's good. If I have errors, I can still click the save button and it'll try to calculate. That's not good. Because that's not right. I ordered 55,000 whatever cheese sticks and it cost me $1 and that can't be right. The reason it's not right is because we have all these errors on the form here. And the GUI ought to be smart enough, don't you think, that if there's red error markers on the form, that it shouldn't be going and saving stuff? That shouldn't happen. The GUI should be smart enough to say, if I got error markers, don't even ask the business class to do the math because it don't make any sense. And the other side of the story is the business class should not be sending an answer going, hey, we still got errors. So no, I'm not doing that. What we're going to do after the break is come back and write two more methods. One for the GUI that says, you got any error markers on the form? If so, tell the user, no, I'm not saving. I'm not even going to ask. That's a method. It's not an event. It'll be tied to button save. Okay, so whenever I try to save, it'll first check to see if there's any error markers on the form. If there aren't, then it'll save. If there are, it'll throw a fit. It'll display a message box. Then we'll write another method that goes into the business class and said, okay, there's no error markers on the form, but maybe he never touched the last name box, and that's required. Maybe he never set a size, that's required. Send a message back to the business class going, no, I'm not saving because we still got errors. Even though you don't show any on your form, I know, business class says, that there's still errors. When we get those two done, and I think I can do them in the next hour, we are done. That's the end of the unit. And you're now ready to go out to write your own validation routines, which is perfect timing because now you're done writing your assignment tracker anyways, hopefully. Most of you were in the RDD class last hour when I gave you the lecture about breaking these programs into parts and doing them over time because they don't get written in one day anymore. Real hard to do. So I'm not going to say that again.